Hello, I am AliEkberBüyükturgay and welcome to our Industrial Automation Course project presentation. Our project topic is Automated Car Washing System. With this project, we try to create an automated car washing system with new and productive approach. Now I will give a brief introduction of our project and then let my group mates continue with these contents. We have some information about our group and lesson on this page. The general marketplace of car washing system is dominated by simple programmed car washing framework system. Although programmed auto washing framework is extremely common and widely used, we want to investigate the modern and upgraded approach for our project. Today, while we are living in extreme conditions of COVID-19 pandemic, we now realize more than ever that our planet's resources are limited and we should develop more efficient systems and processes with automation technology that we constantly improve.
Hi, I'm Banu Pekan. Now I will explain the contents. We prioritize three major things: nature, human, and industrial applicability. With the help of sensors, vehicle sizes can be obtained to optimize the water, shampoo, and energy consumption. This will give us a major advantages. When the project will be completed and put into use, it was asked to be more respectful and beneficial to the environment in terms of nature, to have a more usable and protective environment for human beings, and to reduce the costs in the industry. Let's use the raw materials, change it when necessary. For the scope, we try to create a system that is automated and aware of vehicle positioning when needed. Also, we plan it to have an automation platform on which the car will move. We try to create a whole system without any human touch. We will control the system by PLC, also have an emergency control and system monitoring interface. These are our technical requirements for the system that we plan to create. We want to be able to determine the position of the vehicle in the desired location. Also, we want to determine the exact car size for our brushing and washing system. We want our system to be an unmanned system, so we will automate it, valve and heater system for washing and drying. We want to automate design and control the whole system by PLC controller. So if you look at our system in mind, we need to have 15 input-output PLC modules. We also want to create a human-machine interface for emergency and monitoring of the system.
I'm Nakber. This schematic is our basic system structure for automated car washing system. As you can see, we have two washing processes, one brushing and drying process. Process will use sensors and move with or conveyor motor. We can define the system structure of our automated car project in 7 stages. This 7 stages, which respectively are start, shampoo process, brush, water, spray, dry process, and the last one is exit. We have started the simple working principle of this 7 stages in our flowchart. Our process monitored with the help of sensors. Our sensors follow the ratio from entry and exit and starts or does not initiate stages. As a result, our flowchart shows the system is an understable way.
Now let's move into the simulation coding of the program. For starting the system, first we need to activate the system start. For this, we have a button in human-machine interface. After this, we need to activate the proximity sensor. After proximity sensor activation, we can start the process with the car wash start button. This function block has two output. One is for main signal to a continuation of process and other is the ticket output for the ticket number. After the start system will have 3-second delay for safety measurement, then our carrier system start to activate. If F2F signal comes or system stop press, system will stop as will continue until the end. This function block has two error lamps as an output as well. These error lamps are activated according to F2F or proximity signals. When the vehicle moves into the foam part, the foam system function block will be activated with the help of proximity sensors. In this function block, we also calculate the water and shampoo levels of the tanks for safety, and if any of the two is low enough, the error lamp will be activated.
After this vehicle moves into brushing system, in this part the brushing function will be activated with the signals from proximity sensors. As a result, the brush starts to turn. We have two proximity sensors in this section, one in entrance, one in exit. The continuation of the function blocks working when the vehicle in range. Brush up-down function block is for the servo motor control. This function block and ladder is going to move the brush up and down according to vehicles and brushes height. We used a read function block to control clockwise or counterclockwise movements of the servo motors. The re-rating function block is going to be activated when car is enter its proximity. After this part, vehicle will move into the drying function block, we have two sensors working as the same principle as the brushing function block. After the dryer motor activated, temperature sensors will be activated to determine the heat, and from that the system will activate or stand still to rise the heat. The heat will be displayed as an analog output at human-machine interface.
This is for the human-machine interface to relay the analog data. This is the analog output unit for ticket number and current heat, but because this ladder is analog, we can't activate this block unless the system will not work. When the car exits the system, the last sensor will be activated and the system will stop. This is the analog input part for the calculation of the vehicle to brushed instance. Like previously mentioned, if you activate this part, the system will not work. This part should be between in the fourth and fifth ladders. This is our interrupt emergency signals. Any of the signals will make the system stop automatically. Thank you for listening and watching.